So what is a Wilcoxon signed rank test? A Wilcoxon signed rank test is used to determine whether the median of a single continuous variable differs from a specified constant. I think I forgot to put something on the slide here. You can use a continuous variable or an ordinal variable here. So if you failed normality on a one sample t-test, you could use the Wilcoxon signed rank test. Or if you were looking to check an ordinal variable for some reason, you could also do that here. This is a non-parametric test. It does not assume normality. The data does not have to follow that standard bell-shaped curve. And I've left some additional links on the slide in case you were looking for help. We have the U of G SPSS LibGuide or the SPSS documentation for help on that. What are the assumptions of the Wilcoxon signed rank test? There's only one. You need one variable, and it can be continuous or it can be ordinal. How do we check this assumption? Well, we can look at our data. Here we're going to be looking at fake data 1. And we're looking to see, is this continuous? Is this ordinal? If we glance at this data set, we can see that we've got a range of values. We've got a bunch of decimals. Decimals are a pretty big giveaway that it's probably continuous. So we have passed this assumption. We've got continuous data in our fake data 1 data set. If you have passed your assumption, you can proceed to conducting the Wilcoxon signed rank test. Make sure you always check your assumptions, though. To run a Wilcoxon signed rank test, this one is one that SPSS hides a little bit. You're going to click where it says Analyze, Non-Parametric Tests, One Sample. It doesn't have the exact name of the test. If it helps, you can remember that this is the non-parametric equivalent of the one sample t-test. So to find this, you go to where it says Analyze, Non-Parametric Tests, because it's a non-parametric. It does not assume normality. And then the trick is you have to remember which other button to click. It's the non-parametric one sample t-test. So you click where it says one sample. If you have clicked that, it will open the one sample non-parametric tests dialog box. The non-parametric tests are a little frustrating. It's just more options that you need to do. You might have remembered when we did the t-test, we moved one thing, we added one number, we were good to go. Non-parametric is slightly more complicated. In the Objective tab, which is the tab that opens automatically, you need to click where it says Customize Analysis. So in the Objective tab, you click Customize Analysis. Then you click the Fields tab because there's 3 different tabs for non-parametric tests. In the Fields tab, you have to take your one continuous or ordinal column. Here we're using fake data 1. It's continuous. It's got that little yellow ruler next to it. And you move it from the fields section to the test fields section. So you take your one piece, put it where it says test fields. In the settings tab, one last thing we have to do. You're going to click again where it says customize tests. Because non-parametric tests, there are a lot of different options. You have to tell it which one you need. You have to say compare median to hypothesized. And then in brackets, it says Wilcoxon signed rank test. This is our non-parametric equivalent to the one sample t-test. It's the Wilcoxon signed rank test. You have to include a hypothesized median. So this might come from research. This might come from Statistics Canada might have a mean or a median for you to put in here. But this will come from somewhere else. Maybe it's just something you hypothesized. You're like, well, the median cat's tail length might be blank. You put it into your spreadsheet. So here we're going to add a value of 85. And then we click Run. And if you have done that, you will get an output that looks something like this. It looks clunky and a little weird if you're used to parametric tests. But it will give you a hypothesis test summary table, which is essentially going to write out for you what are you testing, what test did you run, what's the p-value of that test, and what should you do about it. This same p-value is going to be further down where it says one sample Wilcoxon signed rank test summary. This table tells you the n or number of observations used, what your test statistic is, your standard error of the test, and then your p-value is going to be this last piece. So you can either read it up top and get the words of what you're supposed to be doing, or you can get it down here at the bottom. if your p-value is less than 0.05, it means that the median of your column of data is different than the test median you've given it. So here we gave a value of 85. Our median value is different than 85 because our p-value is less than 0.05. If p is greater than 0.05, we would be able to say, well, we can't say whether our median is different than the test median. It will also give you a nice little graph that shows you in green the hypothesized median. So that test value you put in, we put in 85. And it will also show you the median of your actual data. So we can see that the green and blue lines are quite far apart, and our p-value is less than 0.05. We have found a difference between our median and the hypothesized median. And that's how you do a Wilcoxon signed right test.